Hello friends, in this video let us discuss the most basic question in machines which arises in every electrical engineering student. So the question is, why transformer is not producing a rotating magnetic field like induction motor? So why induction motor is producing rotating magnetic field and why your transformer is not producing a rotating magnetic field? So to produce a rotating magnetic field, we have a condition. To produce RMF, that is, we have two conditions. The first condition is the supply. You can say it may be either 3-phase or 2-phase or greater than single phase. It can be applied to any number of phases, but it won't apply to your single phase, because for producing torque we need two quantities, that is two windings, but in single phase we are having only one winding. So if we employ other winding in single phase, we can have a rotating magnetic field, but if you are having a single winding, then you cannot have a rotating magnetic field. Now this can be applicable to any number of phases. Now the first condition is you should have a balanced phase supply. Balanced phase supply. And the second condition is you should have spatial distribution of your windings, or you can say spatial arrangement of your windings. Now coming to balanced phase supply, it means either 2-phase or 3-phase or single phase if you are having two windings in single phase, or any for 6-phase, 12-phase. But what happening here is there should be equal phase shift among the currents, then it is said to have a balanced phase supply. Now if there is no equal phase shift among the currents, if I say this is R, Y and B, and if IR, IY and IB, if they are not having equal phase shift among them, then they won't be said as balanced phase supply. Now when all the three currents are displaced equally in time, then only the supply is said to be balanced phase supply. Now coming to the spatial arrangement of winding, it means that whatever the number of windings you have, there should be equal space angle among the windings, So here the currents are displaced equally, and the displacement here is done in time because we are saying the phase shift, and here the displacement done here in space. Now if we go to the transformer, if I take a core type transformer, here you are having a winding, so here you are having a primary winding and here secondary winding. Though you are supplying a balanced phase supply, that means the currents are equally displaced. It may be 90 degrees, just like in your 2-phase induction motor, or in 120 degrees, just like in your 3-phase induction motor. Now if the current are displaced equally, and if the windings are not displaced equally in space domain, then you are not going to have a rotating magnetic field. Now though you are going to supply the balance phase, we are going to supply the balanced current which are displaced equally in time domain, but if the windings are not displaced equally in space domain, then you may not have a rotating magnetic field. Now, if you observe in your induction motor, if you are providing a balanced three-phase supply to a three-phase induction motor, let us say R, Y, B, here the IR, IY and IZ are displaced equally by 120 degrees in time domain. Now, similarly, if you see the windings are also displaced from each other by 120 degrees. That is, the space angle between each winding is 120 degrees. Now, we are having equal phase shift among the currents and equal space angle among the windings. Now, as the two conditions are satisfied in our induction motor, we are going to have a rotating magnetic field. Similarly, this can be applicable to a two-phase induction motor also, where you are having two windings. Let us say in two-phase induction motor, this is your control winding and this is your reference winding, and here is your rotor. Now, the two windings are displaced 90 degrees in space. The two windings are in space quadrature, they are displaced by 90 degrees in space, they are uniformly distributed, you can say, and the flux produced by the current in both the windings are also 90 degrees out of phase. 90 degrees out of phase. That means the currents are equally displaced in time domain. That means you can say you are having a balanced phase supply, and the windings are also equally displaced in space domain. Now, as the two conditions are satisfied, here also you are going to have a rotating magnetic field. Now, similarly, this can be applied for any number of phases. It may be single phase, two phase, three phase, four, 6 phase, 12 phase, any number of phases. If you are having two windings in single phase induction motor, what we are going to have is we are employing a auxiliary winding, and this winding is arranged in such a manner, it is in space quadrature with the main winding, thereby you can have a rotating magnetic field in your single phase induction motor. So, this is the theory behind why transformer is not producing a rotating magnetic field, but why your induction motor are producing a rotating magnetic field. So, I hope you have understood well. Please subscribe to the channel. Thank you.